Okay, so today we are going to work on solving systems of linear equation, and we're using both combination method, or which is also called the elimination method, or substitution method. And depending on the problem, you can choose which method will be easier or which will work the best. So, most of the times the linear combination method, I think, is faster and easier, but there are times when substitution method might be easier or faster. So we'll take a look at both, especially with the fraction coefficient here, and we'll go over how we can deal with those fractions. So on this one, we're going to use the combination method, which means that we're going to have to combine these two equations, and we're going to add the like terms, and we want either the x variable or the y variable to cancel out. So as you can see, the numbers are not going to cancel out if you combine them as they are. So one of the things that you can do is, if you don't like the fraction, you can get rid of the fraction by multiplying by the common denominator, right? So the bottom one here, the denominator is 2, so I can multiply everything at the bottom by 2, and that will get rid of the fraction and make everything into integers. So if I distribute the 2 here, it's going to obviously cancel out the 2, and then that's going to give you 1x, right? So let me do that here. So distribute 2 times 1/2, a half of 2 is going to be 1x. And then here, 2 times -3 is going to be -6y. And then don't forget to multiply with 1 as well. So that's going to be 2 times 1, which is 2, right? So then all of a sudden, we got rid of the fraction, and then this looks, much easier. So then we take a look at this, and I can see here that I got 1x here and 1x here. So if I can turn this into a -1x, then that will cancel out when I combine it with the positive 1x. So what I'm going to do here is, on the top, I'm going to multiply by -1 on everything. So when I do that, that's going to be -1x, or -x. And then negative times negative is going to be positive y, or 1y. And then negative times positive is going to be -17. All right. So then now, using the combination method or the elimination method, we're going to combine these two equations, and you can tell that it's going to eliminate the x variable, because -1x and positive 1x is 0x. So the x is eliminated there. And then this is 1y, and -6y is going to be -5y. And -17 and positive 2 is going to be -15. And then we divide by -5 to cancel out the -5 in front of the y there. So -5 divided by -5 cancels out to 1. So 1y is just y, and then negative divided by negative is positive, and that's going to be +3. So we were able to figure out y as +3, and then what we could do is we can substitute into either of these two equations. Obviously, the top one's going to be easier, right? It's going to give you the same answer, but the top one is going to be easier. So we're going to substitute y with 3 on the top. So we're going to do that to the top equation. So that's going to be x, and then minus, and then the y is going to be 3. It's equals 17. And then we're going to move that to the other side by doing the opposite of subtracting, which is adding. And then that's going to give us x equals 20. And so we were able to figure out the answer fairly quickly using the combination method. And so we put it together, x first, so that's 20, comma, y, which is 3. So if you were to graph it, once again, just reviewing what that means, the solution for the systems of linear equation means where the two lines, if you were to graph it, it's going to intersect. So the solution is where these two lines, it's going to intersect at the location 20, 3. Okay. Now, if you had chosen the substitution method, you would have gotten the same answer. You would probably have substituted using the first equation and isolate either the x or the y, and then substitute into the other equation, right? You can still change this if you don't like the fraction and multiply by 2 first, and then substitute into this equation if you don't like the fraction. And that will give you the same answer, okay? All right, so then what I'm gonna do is I'm gonna show you another example here, and then we're gonna use a substitution method. Again, there's a fraction here, right? So that makes it a little bit more difficult. And obviously, I don't like that fraction. So you could either get rid of the fraction first, or you can isolate the y first, either way, right? Because the y is by itself. I'm gonna get rid of the fraction first, because that's always the kind of the easier way, right? Because most of us don't want to work with the fraction. So it's, again, to do that, you multiply by the common denominator. In this case is 3. So you multiply everything by 3 on the top, and 3 times 1/3 is going to be 1x, or just x. And then 3 times y is going to be 3y. And 3 times 9, don't forget to multiply that, is going to be 27. So notice now we have the x by itself, or the 1 there is invisible. So we have the x here. So if we're using the substitution method, remember we want to isolate one variable on one side. So we want to move this to the other side, right, by doing the opposite of this. So then x is by itself, and this is 27 minus 3y, or negative 3y first, plus 27. So we want to always, you know, get in the good habit of putting the variable first, because this is kind of like the linear format, even though the x is in the front, like y equals mx plus b. So then once we have the x by itself, we're going to substitute this, the negative 3y plus 27, into the x in the other equation here, right? So we're going to substitute this into the x in the other equation. So we're going to rewrite it with negative 2, parentheses, negative 3y plus 27. And then we're going to copy the rest, plus 2y is equal to negative 6. So it's always, you know, helpful, or remember to always put in parentheses so you don't forget to distribute, right? And so when I distribute this, negative times negative is going to be positive 6y, and then negative times positive is going to be negative. It's going to be a huge number, but you know, 27 times 2 is going to be 54, and it's going to be negative, so you put minus, right? And then copy the rest. And then obviously now we got one variable with the y here and here, so we're going to combine that. So 6y plus 2y is going to be 8y. And then we're going to copy the rest. And then negative 6 was in the other side. And then we're going to isolate the y. So we're going to add 54 to both sides of the equation to cancel that out. That leaves us with 8y is equal to, so this is negative 6 plus 54, which is like 54 minus 6, which is positive 48. And then we divide by 8, because that's 8 times y, so the opposite of multiplication is division. So 8 divided by 8 is 1y, or just y, and 48 divided by 8 is 6. So y is equal to 6. And so now we figured out y, we have to figure out x first by substituting back in. So once again, you can plug into the original equation, but the new equation that we found here seems to be much easier now, granted that we did everything correctly up to this point. So if you did everything correctly here, it will be probably easier to substitute into this. So that would be x equals negative 3 times y, which is 6 that we just found, plus 27. And so x is going to be negative 18 plus 27. And so since this is opposite sign, even though you see the plus operation here, this is negative and positive, so you would have to subtract. So it's 27 minus 18, which is 9, positive 9, right? So x is going to be positive 9. And so we found both x and y. And so you put it together. And so you put x first, which is 9, comma, y, which is 6. So once again, that is our solution, which means that if you were to check it algebraically, if you plugged in 9 into the x and 6 into the y, that would equal to 9, and so that would check. And then if you plugged in 9 into the x and then 6 into the y, that should equal to -6. So that's how you can check it algebraically. Also, again, this is the intersection where these two lines, if you were to graph them, would intersect. So it's always good to remember what the solution always means, right? So when you're talking about systems of equations, this is linear equation, but it would also work later on when you're doing systems of equation, whether it's linear or quadratic or even other functions. The solution is always where the different graph, whether it's a line or a parabola or any other shape, where they intersect, right? So that's what the solution means. In this case, they will intersect at 9,6. Okay. All right. So that's how you solve systems of linear equation using either combination or substitution method. And so you can choose any method you want. Combination method, or it's also called the elimination method, seems to be easier. That seems to be the choice for most of the students. But sometimes you can use substitution method because that would actually, believe it or not, be easier sometimes and even faster. Okay. All right, so good luck with that. All right, see you next time.